Okay, back here again with the Hall effect part of the job build, whatever you want to call it. Position this again. Shouldn't be too bad. Got some different music there now, so. Just royalty free playlist. Not a playlist, just whatever plays. So I've got one of the Hall effects here done. So they have to be opposite to each other, the way they work. So put them marked out, just mark them, try to use the heat shrinks and stuff. I also have the wire here marked, a little red dot on this one. Center is always ground, so they'll be like this, reversed to each other here. Then I'll end up heat shrinking them all together, like this one is. Which is two there. It's a little bit shorter, but it's still gonna work out for what I want to use it for on this one. So that's what I'm gonna do here on this one. I skipped a little bit here, and also didn't show, but I connected the positive here for this one here too. Right there. Everything's all hooked up with that. Just have the Hall effect circuit here left. So I'm going to show here what I do. These ones are really sensitive to being bent here at the on the chip here itself, so be really careful when you bend these. I like to spread them apart, that way you can get heat shrink on them. Get some little bit of flux on them. Test some putting some flux on these wires, make sure you get good contact. This is high quality BJA flux from Black Horse Repairs. Really good. Best flux I've ever used. All natural too. Yeah, it's pretty hot. Too hot. Actually almost done. This circuit. Not much left here. This wire sucks. Clean it up. Well, I was smart. What a bonehead I am. Or a brainwave. Oops. Always backwards anyway, compared to what I want. I did backwards anyway. Just gonna go to my hot air station and these have to be opposite to each other, like this. I'll need much, just want to have it so that I can keep them exactly next to each other. Remember which stuff I used before. I'm gonna this one. It's heavy duty, you know. Okay, so I'm just gonna go to my hot air station and shrink this. See, they're opposite to each other. I want to try to get them just a little bit tighter together. Put this on there and then I'll shrink this one too. It'll hold them tight. That's pretty good now. So I've got this here marked out. It doesn't matter which one goes where, because it's just going to matter the orientation on the... What's this music? The orientation on the rotor. If you gotta switch it around, it'll just depend on your which way it's facing. Does this suck? Better than that. So. Well, they're reversed to the one in here, but whatever, doesn't matter. I just reverse my paint. Change these. Spread them apart. Tuck them in there quickly. This tip sucks. Okay, so the reds will get their power. So whichever, we'll just keep it simple. Take this one and put to this circuit, and this one will go to this circuit. So the reds come from the power source right here. Or no, they come from the signal. Yeah, power source. This one goes here, and then There's some resistors involved in there first. I go in here for resistors, I don't remember. Ooh, gonna need digital out here. This is the red one. Just go straight in. And then there's a 2.2K before this, for the base here. Oh yeah, okay. I know where I'm thinking that there's another resistor I need to put in, and I think it's right here, this one. Another 2.2 from the regulator. Right there. Yeah, this is important. Make sure you have it on the feed side of your circuit for your timer. Don't be taken directly from your input. Another 2.2K there also. Right there. This one here. This one isn't needed. That's a mistake going here too. No, I do use it like that too. Ideally, you hook this to here, the B to E, B to C. That doesn't matter though, as long as it gets taken back down. It's just there to make it a little faster, that's all. so now the rest of it can be done from underneath here. So just point out what I gotta do here. So positive right here goes to this one, to your signal from your timer. Ground goes right here. And that's it for that side of the whole effect. Then you do the other one the same. But first I'll end up hooking up the transistor, give it its power, which is going to come from this one right here. I have to put a 2.2K resistor right here, and it'll go to this right here. There to there. I might be able to just use a resistor for that. No jumpers. Cut that, I should. Probably won't work now. Too short. No, I'm hooking up the ground. Trying to hurry. This video is really long. So. I hate it when these tips don't hold the solder at the tip. Side's done except for the resistor. Why do I have a 1.2? Nope. So, okay. This one to this one. That side should be hooked up. Should be good. Do the same for the other side, you know. Just making sure everything's the right color here. So this one here. Goes to the emitter, the transistor. Or I mean the base, not the emitter. Trying to do it without any jumpers. Use the resistor wire. Iron it there. Probably gonna have to use a little jumper here just to get across these wires here without shorting anything out. Probably the best way, use a jumper. Do the ground next. Which is just right here. Goes right here. And just bridge that with solder. Or a small little chunk of metal here. One more. Actually, that one too can be just bridge. And then give the emitter its power supply. We're 2.2K. So I need to be from the emitter right here to here. See, that's what I just did. Let's see for that. Okay, I think it's done. Let's take a quick look here and see if I see anything else that I missed. Sort of enjoying those look pretty good. I'd also connected the gate to the collector off camera. I did that earlier. It's all connected. It looks like it's ready. I'm gonna hook her up. So I'll be back once I get it all hooked up. Okay, so I've got everything here all hooked up. I ended up having to change this transistor here. I damaged it when I was bending the pins. And I ended up putting the 18K resistors in here too, just between the B and the base and the emitter. You don't want to put them between the base and the collector because that automatically will make your FET turn on. You don't need them either. You don't need those resistors. I just like to have them in there to bring it to ground. Or not the ground, because it is opposite. It's a PNP, but you know what I mean. It's just turns the transistor off faster and stops it from vibrating. Any oscillations after it does turn off. So I got the scope here. These are 60 volts. I don't know. No, I can't remember what these ones are. There's 3 volts each. That's not the 60 volt one. Should be like 15 or so when it's really bright. 15 volts. But they're not going to be very bright because I have this incandescent in here too. Which you need that on there to show it, make it show up on the scope better. You can see this is the top side here. Just holding the magnet right here. So you can see the lights are dim. Battery voltage isn't high enough to turn it on bright enough. But you can see that one's lighting, so I'm going to turn the magnet around here now. Just flipping it. Now, when the top one turns on. See, those are turning on. It's just not holding the magnet in the right place here. Then there's the bottom. See, now it's negative. I'll flip the magnet around. Now the other lights turn on. The other side of the circuit turns on. It's a bit of a different frequency, but that's what it's at. Flip it over again. There you go. So let's put it up here. Turn it on. That one's on. Turn this way. The other one's on. So that's how it works. It's not very bright or anything right now. See if we can turn them up. It's not enough voltage in the battery to get them bright. Works anyway. Success. Another one built. But super long video, but that's the whole build video. It's just, it's all of this here, except for like what I said, you just gotta, your second circuit, your positive is right here, your negative is there, and these resistors are after that, they're here. I've got 2 here per side, per pole. But hope that helps anyways. One of these days I'll draw it out when I have more time, but for now that's what I got. Thanks for watching, guys. Oh, and this circuit's going to be getting the upgraded FETs in it. I have some 100-volt ones coming in pins. And, I think they're good for 40 amps, 100-volt 40 amps. I know they're good, they work, and I've used them before. And probably gonna try the putting these ones in there, the 100 amp, 500 volt. They're 2500 watt heat dissipation. So those are, I've never blown one of those, and I put them through some wicked torture tests. Thanks to K Energy for showing me those ones. But thanks, guys.